Okay, good morning. So let us start with our first problem of assignment. So in AutoCAD sheet number 3, isometric projection, three questions are there. Question number 1, question number 2, question number 3. All these three problems, you have to solve it on one single sheet. Okay, here you have to solve question number 1, 2, and 3. So let us concentrate on question number 1 first. So what we do actually in isometric projection, we calculate the maximum length, we calculate maximum height and maximum width of the problem. Okay. So can anyone tell me the maximum length? So question arises, which is our front view, which is our side view, right? So let us consider this as a front view and this one as a side view because origin is given on this side. Okay. So this will be the front view of a given question. So length is how much? 70 plus 42, right? 112. Height, how much will be the height of that question? Height will be 14 plus 56, right? 14 mm plus 56, that is equal to 70. 70 plus 42, 112, right? And width will be equal to 18 plus 44 plus 22, 84, right? So let us start. I will select projection line first, L enter, horizontal line. Okay. Now starting from this point, maximum length. So whenever we are working in isometric, what you have to do? Snap settings, go to isometric snap, click OK. Right now we are working in isometric snap. Now, how much is the length? 112. Height F5. Okay, change the plane. 112. Then again 112, 112. Okay, F5. Width is how much? 84. Vertical distance 112. Again 84. Okay, then L enter from this point. Then again we have to change the plane F5. This will be 112 and again 84. Okay. So now you can see that our question is going out of the screen. So what I can do, I'll select this part. I will say move, MOVE. Okay. Then I will select a base point. From this point I want to move. I will switch off my orthographic mode and I can adjust the question so that it will be fitting inside the paper. Is that clear? Now the question is exactly inside the paper. Okay, so what we have done, we have calculated this as a front view, considering this as a front view. So origin is at this side. So this is the side view of a given question. So side view, so here you will get the origin if it is side view. This is the front view. Length is 112, height is 112, and width is 84, right? Now, if you see, in such type of question, we have to start from the rear side because the rear plate is flat. So let us concentrate on the rear portion, right? So how much is the height? 14 millimeter. Then there is a radius of 56 and again 26 millimeter horizontal line, 42 millimeter vertical line. Okay. So let us start from the rear portion. Outline. Yes, everyone, please concentrate on screen. Later on, you can draw, right? Starting from this point, how much is the vertical distance? What we have to do, our ortho should be on. Okay. And we'll change the plane. Vertical is how much? 14 millimeter. Okay. Then from this point, how much is the distance? 56. Vertical distance again, 56. Then if I come back again by distance 56, right? So what this indicate, this is the center for that circle. So if I want to draw a circle, which is the command ellipse, we have to type ellipse. Okay, starting from this point. Sorry, I enter iso circle, and then you have to specify the center. This is the center. How much is the radius? 56. Okay, so we have drawn that circle. So now we are going to use tr trim command, tr double enter, trim of this edge, trim of the other edge. Okay, and you can delete this remaining portion. So only the curvature is required. So that portion I have drawn. Now this line was also drawn for reference. So what I can do, I can convert that into projection line. This line was also drawn for a reference. So what I'll do, I'll convert that into projection line. So only line which is required, I have kept it in a dark. Okay. Now from this point, I have done 14 millimeter I have drawn and this curvature is completed. Now I want to move horizontal by 26 millimeter. So from this point, L enter. From this point, how much will be this distance? 26 millimeter, right? Then vertical distance. How much is the vertical distance? 42 millimeter. Then vertical distance is how much? 42 millimeter. It has to meet at this line. Okay. So by dimension, it has to meet 42 millimeter. Okay. It is meeting, means it is perfect, right? Then how much is this distance? 30 millimeter. So let us take that distance 30 millimeter. Horizontal distance 30 millimeter. Done. Okay. It is matching the point. Now thickness. How much is the thickness? 18 millimeter. So from this point, F5 change the plane. Okay. 18 millimeter thickness. Again, what I will do? I will change the plane. Okay. This distance will be how much? 30 millimeter. I will close this edge. Okay. Then starting from this point, L enter. Vertical distance F5. Right. How much is that distance? 42 millimeter. Again we'll close this edge, because whenever there is a change in the surface, this is horizontal, this is vertical, so there will be an edge. This is vertical, again there will be horizontal, so I have drawn that edge. Okay. L enter. Now from this point, how much is the distance? 26 millimeter. Again there will be an edge, right? So this is horizontal. From this part it will be curvature. Now how to draw this curve portion? So what I have to do, I will select copy. Okay. Now which point I will select? We need to select the base point. So what I will do, I will select this as a base point and I will copy with that same point on the other side. So you will get a copy of that curvature. Now starting from this point, how much is the vertical distance? 14 millimeter. I have taken that, right? Then close this geometry. Similarly, L enter, close this geometry. So we have drawn the rear portion of that plate. Any difficulty in this? Okay. Now this much portion we have drawn. Now let us concentrate on this part. Okay, from this edge. Okay, from this edge, the distance is how much? 70 millimeter. And here it is having a radius of 22 millimeter. Means this height is how much? 44 millimeter. Okay, so let us first draw the 70 millimeter line. So where that line will be? L enter. From this point, this line will be 70 millimeter drawn. Then from that point, how much will be the vertical distance? It will be 44 millimeter. Okay. Then, okay, what I have done, this 70 millimeter line I have drawn, and this vertical distance that we have calculated, that the radius of this semicircle is 22. So the height diameter will be equal to 44. So same dimension is there, 44 millimeter. Then from this point, how much is this distance? 44 millimeter. So L enter. From this point. Okay. Change the plane F5. This point it will be 44 millimeter. Then again vertical distance 44 millimeter. And then I will close this point by same dimension 44 millimeter. It is meeting at that point. Okay. Done. Now, from this point, I want to draw a curvature, right? A semicircle. So for that, what is the command? Ellipse. Okay. Type ellipse. Then I enter isocircle. Specify the center and radius you can give. Directly we can give that radius. TR double enter. Trim off this edge. Trim off this. Okay. That portion I can keep. Okay. TR double enter. This portion I will trim it off, and this I can convert into a center line, because this will represent the center of that circle. So I will convert it into center line. Now same thing will be there at a distance of 42 millimeter. This 42 millimeter need to be drawn. So same geometry will be there. So what I will do, I will copy this. I will copy this semicircle. Okay. Copy, CO, enter. Then you have to select the base point. So I'll select this as a base point, and then I want to copy it in this plane, right isoplane. So you select right isoplane. Okay. And in this plane, we need to copy how much is the distance? 42 millimeter. Okay. Done. So you can see that the same thing has been touched there. Okay. Now L enter. Starting from this point here, you can see that there is a change of surface. This is vertical surface, this is horizontal surface. Whenever there is a change of surface, so there will be an edge. So this will represent that this one is vertical, this one is the horizontal. Similarly, here from this point, okay, you will get that vertical edge. Okay, but now what I have done, I have not drawn this rib. Okay, rib I have not drawn, but the remaining portion I have drawn. Now here, L enter. From this point, you can see that you will get this option, quadrant. From that point to quadrant, you connect. Okay, and you can trim it off. Let us check whether we are getting tangent. L enter. Okay, suppose if I select this point and then, okay, let it be quadrant to quadrant, then you can trim this portion. Okay, this portion is not required. Okay, so the curve portion we have drawn. Okay, now it is having a hexagonal slot. Hexagonal slot is there. So before that, let us concentrate on this rib. It is having a distance of 14 millimeter from the top. So let us first highlight the point where that rib is going to start. So this point, vertical distance 14 millimeter. How much is the thickness of rib? 10 millimeter. So let us first draw the thickness of rib, 10 millimeter. Okay. So we have drawn the thickness of the rib. Okay. Now, where that rib will end, that rib is tangential to the circle. Okay, we don't know how much is this dimension. So it is tangential. So starting from this point, L enter, right? It will be tangential. So are you getting that tangential point? Let us check. Okay, yes. Can you see the symbol of tangent? Okay, so this is the point. Done. Now this portion we have drawn. What I will do, I will select this line. I will select this line. Okay, I will select this tangent. I will select that curvature. Everything. What I have selected, vertical line, a tangent, right? And that horizontal and curvature, I will say copy. Which point you are going to select as a base point? This point as a base point, and this will be the new point. Okay, escape. So I have copied it at same distance. Now you have to use trim option, TR double enter. This portion will not be there. Trim it off. Even this edge will not be visible. So whichever edge is not visible, you can remove that edge. Okay, even this edge is not visible. So remove that. Similarly, this curvature, only this much part will be there. A small part of that curvature will be there. So only that much part we need to show, and all other part we need to trim out. So this is the portion. And we know that in isometric, we don't have to show any hidden line. So this is done with that incline rib. Any difficulty till now? Okay, now let us concentrate on this portion, the hexagon. Okay, so you can see that the dimension of the hexagon is not given completely. It is given only the across flat. So A slash F indicates that it is across flat, means dimension that hexagon is given across the flat edges, from this flat edge to this flat edge. If they have given across the corner, then what will happen? Across the corner means they will give the diameter of that hexagon. Directly we can, with the help of across the corner, we would have directly gotten the length edge of that. But in this case, we need to calculate that edge. So how to calculate that edge? So let us see that calculation. So what I need to do, I need to redraw this hexagon. Okay. So for that, what I will do the construction line now. Okay. So for that, first I will move to normal rectangular snap. Okay, this is, you can do it by calculation or you can draw it on screen. Okay, so across the flat is 30 millimeter. So from center to one of its edge distance will be 15 millimeter. So I will take from this point, vertical distance is 15 millimeter. Is that clear? Okay, and I will draw a horizontal line and I will leave. Right, this distance we know it is, how much is that distance? 15 millimeter. Now let us see, check the angles. Okay, so this hexagon is made up of 6 equilateral triangles. So angle included will be 60, 60, and here also the angle will be 60. Semisec, this, if I take the incline and half of the angle, it will be 30 degree. So from this point, L enter. Okay, what I will do, I don't know the length. Okay, this length I don't know. So what I will do, I will take it more than this wherever it intersects. So let us assume that it is of 30 millimeter. I have just made that assumption. Then you have to press tab on the keyboard. You have to press tab because we have given the input to the length. Now we want to give input to this angle. So you don't press enter, press tab. So when you press tab, it will take to the angle, and now this angle will be equal to 60 degree. Okay, once you take this angle as 60 degree, what will happen? This angle will be equal to 30. Okay, use trim option. Okay, this we have trimmed it off. Now suppose if I create a mirror image of this, mi enter, starting from this point. Okay, so this is the, sorry, mi enter first point on reference point and then enter. Okay, so this is the small part of that hexagon. Now let us draw an hexagon. For that, what we have to select, you have to select here polygon. Okay, number of sides we have to specify how much is that side, 6. Okay, now whether it is an edge or it is a center, so you can select center because we have, so this is the center inscribed, and I can select this. Okay, so I have drawn this hexagon. Is that clear? Now let us check this dimensions across the flat. It is showing 30 millimeter, vertical distance as 30 millimeter. Now how much is the edge? This is 17 millimeter. We have drawn it, or you can do it by calculation. On paper, you can draw a small sketch, and we require this length, that is 17 millimeter. Any difficulty in this? Okay, suppose if I want this distance, how much is this distance? How much will be that? It will be 35 across the corner. Are you getting it? Across the corner also this distance is there. This distance is of 17 millimeter. This will be of 35. Is that clear? Okay. Now let us draw this at this portion. So for that, already vertical center line is there. Let me draw horizontal center line. Okay, for horizontal center line, I can take a reference of this midpoint and I will draw this. Okay, I will, one second. First, we need to go to isometric snap. Okay, it will help me to draw accurate. L enter, midpoint, and then F8. Ortho should be on. Change the plane F5. Okay, so this is nothing but this is representing me. I can change this to center line. Okay, so this is the point where it is going to intersect. I'll enter. Let us check it is, yes, it is a midpoint. Okay, now what we have to do, it is going to place like this. So how much is this distance? 17 millimeter, and vertical distance is 30. So starting from this point, L enter. Starting from this point, vertical distance I will take 15 millimeter. Then on this side, how much will be distance? 17 by 2. Okay. Similarly, on the other side, L enter. Actually, it is 17.5. Okay, 17 by, let us take 17 by 2. Okay, are you getting it? This vertical, so this total distance will be equal to 35. Similarly, L enter from this point, vertical distance 15. You have to take that distance. Then this will be 17 millimeter. Enter. L enter from this point, 17. 17 millimeter. 17 by 2. Yes, yes. L enter from this point. This is 17 by 2. Escape. L enter from this point is 17 by 2. Okay. Then L enter from this point. How much is this distance? 35 by 2. Similarly, this side 35 by 2. Okay. Once you get all these 4 points, what we have to do? L enter to point, connect it. Okay. Similarly, L enter from this point, you connect and you again connect this. Okay. Then these lines are not required. You can trim it off, or you can make it as a projection line. This part is done. Okay, but still there is few thing remaining in this. Okay, it is having, let us check whether the other surface, it will not come because the thickness is 42 millimeter, but there will be few lines which will be visible. This line F5, change the plane. Okay, this line will be visible. L enter, need to check whether this line will be there. Yes, that line will also be there. These two lines, L enter, whether this line is visible. No, this will not be visible. So you have to use TR, double enter, trim this edge, okay, trim this edge. So why we are showing this edge? Because here you can see it is inclined. Similarly, here it will be horizontal surface. This is again another surface angle, and this is, so there will be an edge of that exhibit. Are you getting it? So this is the complete view. So you can hide the projection line, you can hide center line, okay, and this is the final solution of a given question. Are you getting it? Any difficulty in this? So you practice this first question, then I will show how to draw the second and third.